In this demonstration, you'll digitize with coordinate geometry, or COGO. We'll begin by setting up the demo. First, you'll open a new map blank template named demo_3-2 in ArcGIS Pro. Under the project options, you'll set the distance units to US survey foot or feet US and the direction units to QB or quadrant bearing. And then last, you'll download the demo_3-2.pdf to your new project folder from the course website. We'll start on Windows Desktop, where I'll open Windows File Explorer. In Windows File Explorer, I want to browse to my course and demo folder. And then inside my demos folder, this is where we're going to create our new project. And I'll do that using ArcGIS Pro. So I'm going to click on ArcGIS Pro and open it up. And so we'll create the project here, and it will also create the project folder structure in Windows File Explorer. So under New Project, I'm going to click Map, and that opens the new project window that we do from the bottom to the top. We're going to go ahead and let it create a folder for the local project, but we need to set the location for that folder. So I'm going to click on Browse, and then in the new project location window, I'm going to browse to my Demos folder. Click OK. That sets my location for my project to the same location in Windows File Explorer. And then now I need to name my project, and we'll go ahead and call our project demo_3-2. And when we click OK, it opens our new ArcGIS Pro project, but also creates our project folder and supporting files in Windows File Explorer, including the demo_3-2.aprx project file, the demo_3-2 toolbox file, and the demo_3-2.gdb file geodatabase. Now, before we begin, we need to make sure that our direction and distance units for our ArcGIS Pro project are set to the same direction and distance units as our plat. So I'm going to click on the project pane and then the options. And in the options window, we can set the options for this particular project. In this case, I want to go to the units section, and under distance units, set my default distance units to foot_US. And then in the direction units section, set my direction units to quadrant bearing. Go ahead and click OK. To return to the project, click the back button, and that returns to our ArcGIS Pro project file. Now we need to download our demo data. I've already done it from the course website, and I'm just going to right click and paste it directly in the demo_3-2 folder. Now we're set up to perform our demonstration. In step 2, you'll record the COGO from the plat to a text document. And we'll do this because it's a fairly complex process and it's very easy to make mistakes. So we want to simplify it by interpreting the plat, identifying the COGO courses on that plat, and then listing them out on a text document. So we'll begin by opening up the demo_3-2 Adobe PDF. We'll also open a new Notepad text document, and then we'll record the point of beginning and COGO course dimensions from the plat to our text document and save our changes. All right, back in Windows File Explorer, I'm going to double click on our PDF document to open it up. I also want to open up a blank Notepad document. So I'm going to go to the Start button, type in Notepad, and then I'm going to dock my applications side by side and maybe give a little more desktop to my plat so it's a little bit easier to read. All right, so this is a plat for a subdivision, and if I zoom in on the lower left corner, I can see that it was created by Premier Design and Engineering, and it's the Washington Vista Phase 5B, and it's a final plat that was submitted on a specific date. And the vicinity map shows the neighborhood it's in. It's at the top of the neighborhood between Washington Parkway and Tortoise Circle. And then it includes the coordinate geometry or traverses for the boundary as well as the individual lots within phase 5B. And so we're going to focus on capturing the coordinate geometry for the boundary survey. And that starts at the POB. POB stands for point of beginning, and it needs to be an actual location on the Earth. And so it's not listed on the plat, but I'm going to give it to you. So over in our notepad document, I'm going to type POB, and I want to zoom in a little bit on my text just to make it a little more legible. And then click enter on the keyboard, and we're going to enter in the coordinates for the point of beginning, which starts at longitude 113.5234704 west of the prime meridian, and the units are in decimal degrees or DD. Go ahead and click enter, and then it's latitude 37.1581900 north of the equator in decimal degrees. Now that we've recorded our POB coordinates, we need to enter in our first arc, which is going to be listed as A1, and we can find it in the plat clockwise from the point of beginning. So if I zoom in my plat, I can see my first course, which is the direction and the distance. And I need to record those in my text document. So the direction is north 89 degrees, 19 minutes, and 59 seconds west. And the distance is 329.64 feet. Make sure that you recorded it correctly. So go ahead and check that, make sure you got the right direction and distance, because if there are any errors, there will ultimately be an error in your COGO that you enter in and create in GIS. Now we need to enter in our second course, which is going to be a curve, and you can see the parameters listed right there on the document. And this is a tangent curve because it's coming smoothly off a straight line. So we'll list this in our document as C1, and it's coming off the line north 89, 19, 59 west, and it's a tangent bearing curve, or TB. And then I'm going to go ahead and enter and hit 3 more spaces, and then enter in the radius. And the radius is listed on the plat document there. It's R equals 50, and it's going to the left, so we're going to enter in it as negative 50.00 feet. And go ahead and click enter again in 3 spaces. And this time we need to enter in the parameter for the delta angle. And the delta angle is listed there. It's that little triangle. That's the delta, and the angle is in degrees, minutes, seconds. So we'll capture that in our text document, 109 degrees, 53 minutes, and 56 seconds. And the units are in DMS, or degrees, minutes, seconds. Go ahead and hit enter. And then now we're going to record our second arc. So we'll call it A2 and enter in the direction south 70-46-04 west, and the distance is 102.77 feet. Click enter. Now we need to record our third course. There you can see the direction and dimensions, the direction and distance. It's A3 north 20-44-13 west, 25.79 feet. I'm going to go ahead and speed up the video here now that you know the protocol, and I'll slow it down as we complete arc 7, 30 feet, so that we can capture our second curve, because that's the most complex portion in coordinate geometry. And so there you can see our second curve. It's a really slight, small curve, and there are the dimensions. So I'll list this in my document as C2, and it's coming off a line that is north 11-47-43 west. but it's not coming off as a tangent bearing curve, it's a radial bearing curve. So we'll enter it as RB, enter 3 spaces, and then now the radius is negative 853.00 feet. And then the delta angle is 0, 1, 57 in DMS. And then I'll speed up the video again as we record the final 2 arcs in our boundary survey. And once you're completed recording the traverse, make sure that you check your work, that you review all of the course calls, and that you've recorded them correctly in your text document. Once you do that, now it's time to save your document. So I'll go up to File and click on Save As. And in the Save As window, I'm going to browse to my project home folder and rename my document as kogo.txt and click Save. And there you can see it's updated the Notepad text document name. All right, now we're ready to digitize with Kogo in GIS.